Hi, welcome back to Unit B. We are in Chapter 2, The Chemical Legacy of Human Activity, and this is the first lesson, and it is about organic chemistry. So in this chapter, we're looking at organic compounds. We're going to look at how to name them, identify them, and then how they affect their environment and human health. So there are some of the outcomes for you to get familiar with, and these are our textbook pages. Right, so this lesson has been cut into two parts because it is quite long. So we're starting off with alkanes, or first we're going to actually look at carbon. So all the compounds, when we're talking about an organic compound, we're talking about compounds that are made up of carbon. Okay. And this is really key. Organic compounds are made up of carbon, and carbon is so special because it can form 4 bonds. And these 4 bonds allow it to make big, long carbon chains and add other elements into these big chains, so you can make millions of different organic compounds. Okay, so usually you will see carbon written like this, and it'll be attached. So each of these lines is a bond. Okay, and carbon always forms 4 bonds. Now, it can form a double bond. You see how there's 2 lines here. It can form a double bond with like another carbon. You might see another carbon at the end. Or it could form single bonds to another carbon, or the single bond could be to a hydrogen. If it's to another carbon, then that carbon could have another 4 bonds. So you can start to see how these chains get longer. And they can become quite unique because there could be an oxygen in there as well. And then an oxygen can form another bond. So you have a lot of variety that you can create with these carbons. The key thing is you need to remember is that carbon always forms 4 bonds. So you need to have 4 of these lines or representing bonds coming out of each carbon. Here is a case where carbon has a triple bond, see the 3 lines, and then a single bond to something else. All right. So let's just look at some basic hydrocarbon examples. This is butane, and you'll see in butane you have these black balls are considered carbon. So these are carbons. So there are 4 carbons. And then each of these yellow balls are representing hydrogen atoms. So each of these is a hydrogen. And hydrogen only forms 1 bond, okay? Whereas carbon forms 4. All right, so each of these extra bonds that carbon had fills up with a hydrogen, and you can see that is butane. So you have a 3D representation in a model here, and then you have the expanded form down below where you can see each carbon with all the hydrogens attached. So this first carbon has 3 hydrogens attached to the center carbon, and that's exactly what this expanded formula is showing you, attached to a carbon. So butane is a type of fuel that you find in those barbecue lighters. There are lots of different fuels that are hydrocarbons, and when you hear the word hydrocarbon, you should remember from the first unit, I think it was, that these are made up of hydrogen and carbon only. Okay. So there's another example here of ethene. Ethene has 2 carbons in it. And you'll see here is a double bond between those carbons. So 2 of the carbon bonds are used up to attach in a double bond. And then the other 2 bonds on each carbon are going to a hydrogen. And so you see the molecular 3D formula. And then you can see the actual expanded formula. There you go. And ethene and polyethylene, which is poly means many, so there's a whole bunch of ethene molecules together, are used in the creation of plastic bags. And then you have ethine. You see that Y-N-E? That Y tells you have a triple bond. And we're going to learn more about triple bonds and double bonds later and how the naming works. But just for now, so you can see some of these different hydrocarbon examples. And you might have heard of polyvinyl chloride, PVC, which is used to make rain gear and other waterproof materials. So we will learn how to name all those compounds we just looked at, but now we're going to start with the basics. So right now we're going to look at alkanes. Okay. Alkanes are hydrocarbons, so they're just made of hydrogen and carbon still, and they only form single bonds. Okay, so there's no double or triple bonds like I showed you on the last page between the carbons, so just single bonds. And because there's only single bonds, these are considered saturated. That means they contain as much hydrogen as they possibly can. So if you have a single carbon compound and you only want one carbon in that compound, all 4 bonds around that carbon are going to be filled with hydrogen. And that means it's saturated. Every bond carbon has is filled with hydrogens. So this is actually an example of methane I've just drawn out, CH4. Now, all alkanes are represented by this general formula, and they'll all fit into there. So in this methane molecule, we have 1 carbon, right? So CN, N would be 1 in this case. If N is 1, that means you have 1 carbon. If N is 1, so how many hydrogens would you have? You go 2 times the 1 plus 2. So 2 times 1 plus 2 is just 2 times 1 is 2 plus 2 is 4. So according to this formula here, you would have 4 hydrogens. So CH4, and that's 1, 2, 3, 4. So our formula works. So in this next case here, you're going to have 2 carbons. It says 2 carbons and 6 hydrogens. So if we have 2 carbons, the carbons are always going to be attached together like that. So first you make the big long carbon chain, and then you fill in your hydrogens. So we know that all the remaining bonds around carbon are going to be filled by hydrogens when we're talking about an alkane. Remember that each carbon has 4 bonds. So right now each carbon already has 1 bond with each other. So we're going to put the other 2, 3, 4 bonds around carbon. 2, 3, 4. Now, each of those bonds is going to be attached to a hydrogen. So they're going to find a hydrogen on the other end of each of those bonds. So this is ethane. You can see the only thing that carbon is attached to is either a single bond to another carbon or a single bond to a hydrogen. Right? And that's what makes it an alkane. Yes, so you'll also see this naming chart. This is on page 9 of your data booklet. You are going to need your page 9 of your data booklet a lot in this unit. So if you haven't printed it off, make sure you print it off. This actually gives you how to name these alkanes. And you'll see meth, it refers to 1 carbon. So methane, you see A-N-E, just like alkane, A-N-E. Alkane tells us this carbon chain has single bonded carbons all filled up with hydrogens. If you see meth in front of it, that tells you there's just 1 carbon, and there's the formula for it. If you look at ethane, F here tells you there are 2 carbons. So this is just something you need to start to know. You don't need to memorize because the data booklet's here, but you do need to understand. Ethane means there's 2 carbons, like we just drew in this picture here. And all the rest of the bonds around carbon are filled up with hydrogens to get 6 hydrogens. Let's look at propane now. Propane has 3 carbons. It tells us that in the chart. So we can start drawing propane. 1, 2, 3 carbon chain. It's always going to be a 3 carbon chain. They always have to attach to each other. And then we're going to fill in the remaining spots with hydrogen. So 1, remember every carbon has to have 4 bonds, and you can make them always like flat at 90 degrees to each other when you're drawing the expanded formula. Hydrogen and hydrogen. So how many did we draw? We added 3 on either carbon on the ends and 2 in the middle carbon. So that's 6, 7, 8. So 8, and you'll see in the formula H8. Alrighty. Now you can also use this mathematical formula. Say you have a 8 carbon chain, so C8, and you want to figure out how many hydrogens there are. If there's 8 carbons, then you would need to take this 2n plus 2. I'm going to bring it up over here. 2n plus 2 is the formula to figure out how many hydrogens there are in an alkane. N is the number of carbons. So 2 times 8 plus 2. So 16 plus 2. So that would be 18 hydrogens. So that's a quick way to figure out the formula for the alkane. Alrighty. And then you can see they just keep moving on. You got butane, which means there's 4 carbon chain. Pentane means a 5 carbon chain. And then you go on to hexane, 6 carbon chain, and it continues down here all the way up to 10, which is a decane. Okay. All right, so that is naming a straight alkane chain with nothing added on. So, hydrocarbons. We're continuing with alkanes. There are some 3D drawings here, so you can get a better idea of what they look like 3D. So these are 3D molecules. They're not flat. They're not sitting on a paper. They can be turned around. There are these bonds too. The molecules rotate around those bonds too. So these molecules are very flexible and can be rotating. So each of these black circles, that would be a carbon, and the hydrogens are represented by these white circles. Now, in your data booklet, again on page 9, you're going to have this chart. These are all the different organic compounds that you're going to be learning about in Science 30. So you're going to, by the end of this chapter, you're expected to know and recognize all of these different organic compounds. And right now, we've just looked at alkanes, right? So alkanes, they're just carbon and hydrogen compounds with single bonds between everything, and they give you an example and an example of that formula. So they name it and give you an example formula. They tell you the classification as an alkane, and they also give you the general formula of what it will look like. So this table, we're going to keep referring to this every time we look at a new type of organic compound. All right, when we're talking about hydrocarbons or we're drawing organic compounds, there are a few different ways that we can represent them. So the butane, remember, it has 4 carbons in its molecular formula. So C4H10 can be drawn out in 3 different ways. So you have the expanded diagram, which we have already taken a look at, where you see every single bond around the carbon flat on the paper, and you'll see that every carbon has that 4 lines representing each bond around that at 90 degrees angles too. Then you can take the same butane formula and represent it in the condensed diagram. These should be 3s. So you'll see this first carbon, and they're color-coded here too. This first carbon has 1, 2, 3 hydrogens on it. So there's our first carbon, and there's the hydrogens, and there are 3 hydrogens on that first carbon. The second carbon in green, represented by green here, here we go, has 2 hydrogens attached to it. So you draw the carbon, you have your 2 hydrogens. And then your third carbon here has also 2 hydrogens on it, so CH2. And then the last carbon here has 3 hydrogens on it. So this way, you're not showing the lines of the bonds. There's no lines to represent bonds, but you know that every carbon is attached to each other, because that's the only way they can be attached, because hydrogen can only form 1 bond, so it can't attach to anything else. So you know it's a 4 carbon chain, but this shows you how many hydrogens are on each carbon as you go through that chain. Okay. Then you can save even more space using these line structural diagrams. They're kind of funny. So at the end of each of these lines, you know there's, and every bend, you know there's a carbon here. That's what you need to understand. And they're going to be fully filled with hydrogen. So we don't draw any hydrogens in a line structure diagram. We just draw the carbons, and if they're single or double bonds. In this case, they're all single bonds. So all single bonds, and we assume when we draw it like this that the hydrogens are filling up all the rest of the bonds on each carbon. So there's a carbon here that's going to have 3 hydrogens attached. There's a carbon here that has 2 hydrogens, and 3 hydrogens. So something you're going to have to try and get used to. Those line structural diagrams are a little bit trickier. If I was to draw in a double bond here, it would look like that. You would just have 2 lines coming down. And then you would know as soon as you do that, there's an extra bond to the carbon here, so you'd have even less hydrogens on this carbon and this carbon, which we'll get to in a second. Alrighty, so moving on. So let's use some of the rules for naming alkanes. These are the simple ones right now. These you can actually just find these in your data booklet. There are no twists or bends or anything added onto these chains. Basically, right now you have a carbon with 3 hydrogens, 1, 2, 3, attached to another carbon with 2 hydrogens, attached to a third carbon that has 3 hydrogens on it. There's your 3 hydrogens. So this is an alkane. There's no double bonds, no room for anything else to be bonded in here. This is just a 3 carbon chain. And if you go to your page 9 in your data booklet, you'll see a 3 carbon chain is called propane. All right. See if you, on that same data booklet, you'll find the same formula here. There's a 1 carbon with fully filled with hydrogens all around it, and see if you can find that name on your data booklet. The same with the number 3, and check these with your answers here. Now, naming these compounds get a little bit more complicated. You don't need to know too much about this in science, or you don't need to go too much in detail, but you should be able to name like a branch or 2 off of some of these alkanes. So I'm gonna walk you through what's called the IUPAC Rules, International Union of, I forgot the acronym, naming organic compounds. I can't remember exactly, but these are the rules that we're gonna follow. Okay, so it's an international system used around the world. Doesn't matter where you are, what language you're in, you're going to be using these rules to name these compounds. So first step here is you're going to circle and name the longest carbon chain, which is what we call the parent chain. Okay, and that's been done here. Ignoring any bends. So your longest chain might be up and around and down. It doesn't matter. You need to find the longest carbon chain that's in one step. So you can't go up and then come back. You have to be going in one pathway. Okay, so the longest chain in this case is shown. It's a chain of 5 carbons, and we've numbered these carbons too. So first thing, circle and name the longest carbon chain. So a carbon chain that has 5 carbons in it, if you look in your data booklet, which I didn't put on here, you will see data booklet here. Oop, right up there, you'll see a 5 carbon chain is called pent or pentane. Okay. So, and because it's all single bonds, we call it pentane. So there, we name that carbon chain first. All right. Step 2, locate the position of any branches. So branches are any carbons that are chains that are coming off of this main parent chain. And you'll see here is a branch here with 1 carbon and 3 hydrogens. Okay, so we need to name these branches. They're named with the same prefixes as the parent chain, except instead of putting "ane" at the end like we do for the parent chain, we put YL at the end. Ill, it sounds like. So in this case, we have a 1 carbon chain. So we look up our 1 carbon chain. Meth is a 1 carbon chain. Meth, there you go. So methyl will be the name of this branch. So meth tells us it's a 1 carbon chain. YL tells us it's a branch. Methyl. Now we have to tell everybody, where is this branch? Because it could be on carbon 2, 3, 4, 5, anywhere. So we need to number all the carbons and then include the location of the branch using the smallest numerical order possible. So we always want to number this main chain, the parent chain, so that it gives this branch the lowest number possible. In this case, it's right on the middle carbon, so it doesn't matter which end we numbered this chain from. It'll be on carbon 3. So we say it's on 3. 3-methyl. So methyl is on carbon 3. And it's on a pentane chain. All right, let's take another look at another example. So draw the molecule 2-methylpropane. So in this case, instead of naming it, we're going to draw. So we're going to start by drawing the parent chain. First thing we do. So to find the parent chain, it's always the one that ends in ANE, or it's always at the end here, basically. Propane. If we look up propane, prop is a 3-carbon chain. We can see it here. So 3 carbons. So I'm just going to draw out the 3 carbons. I'm not going to add anything else yet. I'm not going to add all my hydrogens in because I need to look at what else is attached to this chain. Then I can number the carbons and draw any branches. So let's call this carbon 1, 2, and 3. Now, I see there is a branch. There's a methyl group. Methyl. I know it's a group because of the YL. Meth. Methane, methyl, meth. Find meth here, and you'll see it's a 1-carbon chain. So I have a 1-carbon chain, and it is on carbon 2. Carbon number 2. So the number always tells you where, and the math tells you what it is. So the where, you've got a methyl group, which is just a 1-carbon chain on carbon number 2. Now that's all I've got. So that means all the rest of the bonds for each carbon, because every carbon has to have 4 bonds, all the rest of these bonds are filled up by hydrogens. So make sure the last step is you go back and you make sure every carbon it's filled up with 4 bonds. So if it already has a bond to the carbon beside it, that counts as 1 bond. There's 2, 3, 4. So you add hydrogens so that each carbon is filled up with 4 bonds, either to another carbon or to a hydrogen. All right. Oh, I'm going to draw this out. But the answer is here, but I'm going to draw this out up above so we can just see how this is drawn. So start by drawing the parent chain, propane. So propane, 3 carbons. Hey, wait, I just did this. Sorry, my bad. That's the answer. Okay. That was the answer for people that didn't watch the video. Alrighty, so 2-methylpropane. This is the same one we just drew as well. Okay, so there's the expanded formula diagram, which is the one I find I tend to draw because it's easier to draw when you're drawing, figuring out what the structure looks like. Then you can move to the condensed diagram. So you'll see on the first carbon, you'll see 1, 2, 3 hydrogens. There's our first carbon and 3 hydrogens. Now, this condensed diagram does have a bond between the different carbons, but it doesn't need to, although it helps in this case because you do have a branch, I guess. The second carbon has 1 hydrogen. There it is. And then we have our methyl group added on, the 1 carbon and 3 hydrogens. And then at the end of the compound, we have our single carbon and 3 hydrogens. And then this can be represented by a line diagram, remembering that each end of every line is where a carbon would sit. All right, so here is our 3-carbon chain, and then here is our extra methyl group that was added on. You could think of it that way, or you can turn it around another way too. All right, let's try another one. Draw the molecule 2,2-dimethylpropane. So start always with the parent chain. What is the main long chain? In this case, it's propane again. So propane, if you look in your chart, propane right there, 3-carbon chain. So we're just going to do 1, 2, 3. And then we're going to number the carbons to draw these branches. 1, 2, 3. And we're going to see what do we have. We have methyl groups again. And we have this prefix di. Not sure what di means. Di is a prefix. And there's a little chart for all your prefixes. Some of you probably know some of them. Like you've probably heard of Tetra Paks. Tetra is a 4. Mono is a 1. Di is 2. Okay, so that tells me that there are 2 methyl groups. Okay, where are these methyl groups? Well, that's what these numbers tell us. Where are these methyl groups? Both of these methyl groups, it looks like, are on carbon 2. So one methyl on carbon 2 and another methyl on carbon 2. So on carbon 2, we're going to draw 2 methyl groups. Remember, a methyl group, if we look at our chart, a methyl group is just a single carbon. Okay, single carbon chain. So methyl group here and another methyl group below on carbon 2. Lastly, we add enough hydrogen so that all the carbons form 4 bonds. So right now, the middle carbon actually has 4 bonds. They're each filled by other carbons. So we don't add any hydrogen to that. But these carbons on the end of chains are always going to have 3 hydrogens. There we go, 3 hydrogens. Another 3 hydrogens. Oh, I'm seeing a pattern here. And this carbon also needs 3 hydrogens, 3 more bonds. And that is 2,2-dimethylpropane. Right. And then we have the answer key for that one. And again, the same 2,2-dimethylpropane can be written in the condensed form here and the line diagram form. And try and take a look and see how this condensed form lines up to that line diagram. See if you can understand that. Now, be careful. A couple hints. Sometimes you're not going to find the longest chain is the straightest line across. So if you were to look at this and just think long chains can be straight across, you would think, oh, there's 4 carbons. It's a butane chain. Well, no, it actually isn't, because here's your longest chain. 1, 2, 3, 4, 5, right? It's actually pentane. And then this is the group that's been added on. So just be careful. Those will be the ones that kind of you try to get tricked. So you definitely have to look for the longest chain of carbons. This is a great video for you to practice some more naming of alkanes. Definitely watch this video up to 447 and do some more practice. The more you see, the more sense this is going to make. All right, so we're going to take this a step further and we're going to look at alkenes and alkynes. Now, alkenes are also hydrocarbons, so that means they just contain hydrogen and carbon, but they contain double bonds. Remember, we saw those at the beginning, so double bond between the carbons. Okay, and they're considered unsaturated because not every bond around the carbon is filled with hydrogen. So we call it unsaturated. So in theory, we could break these bonds and add some more hydrogen in, and then it would become saturated. Okay. Alkynes are containing triple bonds, and they are also unsaturated because they have these extra bonds to each carbon instead of having all their bonds to hydrogen. So when we name these for alkanes, the ending instead of A-N-E, like methane, or not methane, that's a bad example, like propane, it's going to change to E-N-E, so propene. And then if it's a triple bond, if there's a triple bond in there, it's propyne. So you can see in your chart on page 9 here, we're moving down, we're learning some more of these different organic compounds. This is an alkene. You can see the general formula for it has 2 less hydrogens than the alkane. That's because those hydrogen bonds are used up so that the carbons can form a double bond here. So you can see in this example, instead of having these hydrogens, they're gone. Now these bonds are between carbons. Okay, so that's what's happened to get to the ethene here. So they've lost a hydrogen because you have a double bond. And it's hard to see, but this is actually 2 separate lines. And then here you have a triple bond, which has 3 lines, 1, 2, 3. And you'll see there's only, because the carbons have formed a triple bond, there's only room for 1 more hydrogen on each carbon. Okay, and this is an example of ethine. So here's your example name, your example formula. The classification is alkyne. And then there is your general formula. And you'll see 2 less hydrogens than ethene and then alkane. So basically you lose 2 hydrogens every time you go down. every time you form an extra bond between the carbons. Okay. Alrighty. Yeah, so we talked about the formulas already. There are some examples of what these will look like. So there's ethene, so a double bond between two carbons, which is the one that was on your data booklet. Propene, it's got 3 carbons, 1, 2, 3, and one of them is going to be a double bond. And that leaves room for 1, 2, 3, 4, 5. Oh, I did too many, that's why. Let's just erase one of those bonds. This one's gotta go. Yeah. So why did I do too many? Did anybody notice that? This carbon here has 1, 2 bonds from the double bond, and then you can only take 2 more bonds to the hydrogens. So it can only have 2 more hydrogens on it. This carbon in the middle has 2 bonds used up in its double bond, 1 to this carbon, so it only has room for 1 more hydrogen to be added to it. The carbon on the end, though, only has a single bond, so it has room for the 3 hydrogens to be added on. So that's where the 1, 2, 3, 4, 5, 6 hydrogens come from in propene. All right, let's name some of these alkenes and alkynes. First off, in example 1, is this an alkene or an alkyne? Hopefully you said alkene because there is a double bond here. You can see the double bond. Alrighty, so how many carbons are in the parent chain? So again, same way we're going to name and draw these is we look for the parent chain. So there are 1, 2, 3 carbons in our parent chain. A 3-carbon parent chain, let's just look back at our data booklet. A 3-carbon parent chain is prop, starts with prop. And it has the double bond starting at carbon 1, but if the double bond was over here, it would still be starting at carbon 1. So there's only one place really for propene to have its double bond, so we don't usually have to write the number where the double bond is. So we can just call it propene. Remember, changing the N to E, ending to ENE. There are no groups added on to this propene. However, we could add a group on if we wanted to. We could take this hydrogen off and add a CH4, a methyl group. Oop, that's 4. It's 3. 3 is 3. A methyl group. So if we did that, then we would say on carbon 2, we have a methyl group. So it'd be 2-methyl propene. In our example 2, we have a chain of 2 carbons, 1, 2, and a double bond. So we know it's an alkene. 2-carbon chain, if we look it up, S is a 2-carbon chain. Instead of ethane, we call it ethene. Replace that ane to ene for the double bond. All right, and lastly, example 3, you'll see here we've got carbons. Now remember, this is a bit of a mixture of a condensed diagram and a line diagram. In the center here, this is another carbon, okay, because that's where the lines meet. So there is a carbon there. So our longest chain, I'm going to circle it so it's really obvious, are these carbons. They have to include this triple bond in the longest chain. So include double bonds and triple bonds in your longest chain. So the longest chain has 4 carbons in it. A 4-carbon chain, we'll just look there, is butane, if there was no triple bond, but there is. So instead of butane, we call it butine because of the triple bond. Triple bond. Okay, so that covers the triple bond. The but tells us there are 4 carbons in the chain. And then we need to describe this extra little bit of carbon here. Ooh, we also have to tell everybody, because this triple bond, it could be here, it could be here, it could be in a few different places. We're going to number this chain so that it has the lowest number possible. So this is carbon 1, this is carbon 2, this is carbon 3, this is carbon 4. So our triple bond here starts at carbon number 1. All right, so we need to put that in here. So I'm going to do a little erasing magic here. So that I can show everybody where my triple bond is. I'm going to say my triple bond is on carbon 1, 1-ine. This 1 tells everybody that this is where triple bond on carbon number 1. All right, and then we can put our bute back in here for 4 carbon chain. Then we just need to describe where this methyl group is. The methyl group is on carbon 3. So on carbon 3, we have methyl. So this will be called 3-methyl bute-1-ine. Ugh, what a messy name. But that's what happens with these. They get long, they get messy, they get complicated. But we have these rules that we can use so that we can name any kind of compound. All right, so these are some great places that you can do some practicing here. Let's take a look at some of these. So methane, pretty straightforward. Methane, we can actually just look up right in the data booklet. Ane tells it's an alkane, so no double, triple bond. Meth tells us there's 1 carbon in the carbon chain, so the expanded diagram is just going to be 1 carbon with hydrogens all around it. Condensed, we're just going to write our carbon with our 4 hydrogens right beside it. And then the line diagram, I don't even think you can do a line diagram for that. Let's see, did I put the answer key in here? No, I did not. But I don't think you can do a line diagram because it would be a dot. Propyne is 3 carbons. So you start to get to know some of these after a while. So prop is like that. And when we see ine, that tells us we have a triple bond. Well, where do we put the triple bond? Do we put it here or do we put it here? Because there's no number saying 1 or 2. It doesn't matter. Because if we put it here and then we flip this molecule, it's the same as the other molecule as putting it on this side here. So it doesn't really matter which side you put it on when you only have 3 carbons, because these molecules can be flipped. So it's just a mirror image. So this would be propyne. Let's put on the hydrogens. So this carbon has 3 hydrogens. This carbon already has 4 bonds, so no room for any more hydrogens, and this carbon can just have 1 hydrogen. So if we draw the condensed diagram, the first carbon has 3 hydrogens, the next carbon just has 1 carbon, and then the last carbon just has 1 hydrogen, like that. Then the line diagram for this would be your first carbon to a second carbon to the third carbon, and then this is the triple bond here. So we would have like that. All right, methylpropene. Prop tells us there's 3 carbons. 1, 2, 3. Ene tells us there's a double bond in here. And again, same with the propyne. It doesn't matter which one of these has a double bond because it's the same molecule. So you just pick a spot. There you go. So this becomes carbon 1. 1, 2, 3. And then we have to add a methyl group to carbon 2. So methyl group on carbon 2. And then we're going to fill in the rest of the hydrogens. So this needs 3 hydrogens. And this needs 2 hydrogens. We can do our condensed diagram. So the first carbon here has 3 hydrogens. The next carbon has no hydrogens. We have a methyl group hanging out up here. And then we have a double bond to our carbon with just 2 hydrogens. We don't need to show the double bond because it's a given, because there's not going to be anywhere we would have more hydrogens otherwise, right? Otherwise this would have the CH and this would have CH3, but there must be a carbon double bond in there if you were trying to draw this out. As a line diagram, we would have a first carbon to the second carbon. There's a little methyl group hanging off of it, and then to the last carbon we have a double bond, something like that. All right, so review this as much as you can. Definitely watch the video, and you're going to need to do a lot of practice questions because, you know, I can only do so many. Otherwise, this video will be super, super long. All right, so these are some of the references and resources that I used to create this presentation. So I thank everybody for sharing these resources with me.